Hi. In this video, I'm going to do the other approach to solving vectors problems, right? And this one is vector resolution. So this is when we do the math, we do a little bit of trick. Okay. So I'm going to start by drawing some vectors here. I'm going to say V1, and then I'm going to put maybe V2 here, and V3 here. Okay? And I'm going to add them. And the way we add them is we do head to tail. So I'm basically showing you the proof to what I'm going to be using to solve these problems. Okay? So every vector can be, if it's in 2D, can be broken into an x and a y component. Okay? So this vector here, v1, can be broken into, basically, let's just think about it this way. If you move in this direction, you technically move in right and you move in up. So here is your right component. So I'm going to call that v1 in the x direction. And is your component in the y direction. V1 in the y direction. And I'll do the same thing for this one. And this is going to be V2 in the x direction. This is going to be V3 in the x direction. And I'll do the same thing for the y. So V2y and V3y. Now the resultant, I showed you this before, okay? The resultant is going to be, let me just get a different color. Right, I'm back. Right, so the resultant would be connecting the very first position to the very last arrowhead. So this is my resultant, R. Now the components of that resultant are going to be this green one here and this green one here. So this is going to be RY and RX. Now, if you think about it carefully here, you can see that the relationship between the components, the x components of every vector, and the x component of the resultant. You can see that if you take all the x components and add them up, you end up with the x component of the resultant. And the same is true for the y components. So that's the concept we're going to be using to solve problems with vectors. And I have an example here. So the example is I have three people having a three-way tug of war, right? Okay. Their name are Yad, okay, Maria, and Casey. Okay. So Maria is pulling with 100 newtons, okay, at 40 degrees north of west. Yad is pulling with 175 newtons, and we'll talk about the newtons later in the south of east. And Casey is going to be pulling with 140 newtons at an angle of 70 degrees south of west. Okay? And we're going to try to figure out who's going to win this tug of war. Let me just make some changes here. So if you think about it, this yacht is pulling south of east, so he's going this way. Okay? And this angle here is 10 degrees. Maria is pulling, let me just make sure I got this right. angle here is 40 degrees. Okay, and KC is going south of west. It's pulling in this direction. And this angle here is 70 degrees. Okay? Just want to make sure I got my numbers right. Yeah. So the way we're going to do this, we're going to make a chart. I highly recommend you do a chart. You break your vectors into x and y components. So the force that Maria is exerting, we're going to call it M with an arrow. For Yas, we're going to call it Y. And for Casey, it's C. And then we're going to find the resultant. Now, how do I do this? Well, first I have to figure out which component is positive and which one is negative. So left is negative, down is negative, right and up are both positive. So if you look at Maria, she's going right, that's positive. The x is positive, and up, and y is positive. Yas is going right and left. And down, sorry. Casey is going left, that's negative, and down, which is also negative. Okay? Okay, sorry, Maria, I meant north of west. That's what I meant. Okay, so she's going in this direction. So this is 40. This is Maria. Yeah. This is Casey. Yeah. So which makes Maria negative here. Yep. Okay. Now, if you take this triangle, so I'm just going to do it for Maria, for instance. If you take this triangle here, this is M, and the magnitude of that is 100 newtons. So you have to find out what this x component is, you have to find out the y component is. Now this angle here is 40 degrees. Okay. You can do a little bit of trick, you can do sine and cosine and get the x and the y components. I'm not going to do that, it's expected that you know that. Okay, so these are the values. Now, just like I showed you earlier, to find the components of the resultant, you add the x components and you add the y components. So this is 47.86 and negative 97.67. Okay. Now, you're going to work backwards. So instead of having the resultant, then you're going to break it down. You have the breakdown, and you're going to put the resultant back together. So the x component is positive, so it's going to the right, and it's 47.86. And this y value is negative, which means you're going down. And you still have to do head to tail. You do not put the negative here, okay? Because the drawing shows you that it's negative. Here is your resultant, okay? So you take in the components and you add in them head to tail to get the resultant. R is here. So now how do I figure out R? I can do Pythagorean theorem. By doing this square plus this square and taking the square root, and you need to find out what that angle is, okay? Which I didn't do, but you can figure out what this angle is here, okay? Now, how you find out what this angle is? You do the inverse tangent of the opposite over the adjacent. That's how you do it, okay? I can do the math here for you. So. Actually, yeah, 47.86 squared plus 97.67 squared. We take the square root of that. Okay, so R is going to be 108.77. We'll just go to two decimal places here. Newtons at, we have to figure out what this angle is here. So, second inverse tangent, basically, it's 97.67 divided by 47.86, and that should give us 63.89, so we'll say about 64 degrees. And if you look at it, it's south of east. This is the east and this is the south. So south of east. And And that's it. That's how you do vector resolution. Now, there's another way we can do. We do it in class where we have to use the law of cosines. All right? See you later.